My name is Andy. I'm a brain scientist. I founded a neurotechnology company about 13 years ago. It's called BrainCare 360. It's an international company, so I'm usually working either in Shanghai, Singapore, Malaysia, or somewhere in Asia. My work involves mainly two things. So the first one is education. I travel around Asia to educate scholars in the region on neuroscience, to make neuroscience more approachable, to make neuroscience more fun. I also have a TikTok channel, which I do neuroscience education with short videos to educate general public on the concept of neuroscience. So my second job is translation of neuroscience, meaning that I'm trying to convert and translate a complex neuroscience concept with the help of technology and AI to make neuroscience visible, actionable, and applicable. For instance, we have a brain mapping system which everyone now, without the use of fMRI, everyone now can see how their brain functions. There isn't a really typical day for me. I'm either away from office for teaching. I've ran about 200 neuroscience workshops since 2013. Our largest workshop attracted over 1,000 attendees, sponsored by American College of Sports Medicine. Our latest workshop attracted 400 people. Our topic was on adolescent idiopathic scoliosis. Other than teaching, when I'm in my office, my typical day will be working with the engineers and the neuroscientists on what we do on translational neuroscience. We have various exciting equipments, such as a video oculography looking at the eyes. We have a brain mapping system looking at the brain. We have a gait analysis system looking at human gait function. We have a vestibular training system which tracks the head movements and the vestibular movements. So there are many exciting things about my job. If I was to choose, the most exciting thing about my job would be cracking the scientific myth or problem that exists now. For instance, scoliosis or adolescent idiopathic scoliosis is a scientific myth or a problem. So no one knows the pathophysiology of adolescent idiopathic scoliosis. And the management of scoliosis usually involves the use of something called braces, which is really hard plastic, and you kind of braces the patient and trying to correct their spine, which is very uncomfortable. We found that by using our pool of brain data in the current epidemiology, so meaning that there are 2 to 3% of the adolescent population that have scoliosis and the female to male ratio is 2 to 1, then we discovered that a dysfunctional right parietal lobe is actually responsible or one of the possible causes for scoliosis. To prove that we have a correct hypothesis, trying to activate the parietal lobe with this technique called low light laser therapy, and to see if their scoliosis actually improved. And we have been getting pretty congruent results. So for something like that to crack and to solve a current scientific problem is what really excites me. So the qualification that we need to become a brain scientist or neuroscientist would typically be a bachelor, a master, or PhD in neuroscience. So I have a bachelor in biomedical science, I have a double degree in chiropractic, I also have a degree in osteopathic medicine, and then I have a master degree in clinical medicine, especially neurology. The advice I have for future biologists would be to challenge the status quo. In my opinion, that's how science really progresses. We shouldn't just accept the way things are done blindly. Instead, we should question our daily practices and to think about whether they are the best way to solve an existing problem. By doing that, I believe we will see old problems with a new perspective. And that's often where real breakthrough will happen.